lesson, we're going to talk about how to find the unit rate from a graph. So let's fill in our notes. Unit rate is a ratio that indicates how many units of one quantity there are for every 1 unit of the second quantity. Another term for unit rate is constant of proportionality. So again, if I ask you for the unit rate or if I ask you for the constant of proportionality, I'm asking you for the same thing. I calculate them the exact same way. In math, the letter K represents constant of proportionality or unit rate. A lot of students feel like it should be C, but C already represents something else in math. So again, I didn't make this up, but again, the letter that stands for constant of proportionality is K. We can use the unit rate to create equations that represent proportional relationships. So the equation is going to be in the form y equals kx. So K is going to represent the constant of proportionality. So that's, I'm going to use a number to represent K. Y and X will just stay Y and X in my general equation, but I can use different values and substitute it into that equation to solve for unknown values. Doesn't make a lot of sense right now, but it will after our examples. So the steps to find unit rate from a graph, I need to choose a perfect point where X and Y meet, then divide Y by X, and then express my unit rate using the units. The unit rate is also Y when X equals 1. So this sounds very familiar. It's just like having a table. One thing I want to note is I can write an equation to represent a graph. I can also write an equation to represent a table. We're just going to do a graph today. Example 1. The Science Club is inflating a model of a hot air balloon. The graph below shows their progress. Based on the graph, what is the unit rate? So no matter what pair of points I choose, as long as it's a perfect point, meaning like it hits right at the corner here, it's not halfway in the middle, I'm going to get the same answer. However, for this first problem, I don't have to calculate anything because when X is 1, Y is 10. One thing I want to backtrack and note is on a table, or I'm sorry, on a graph, the Y variable is vertical. And so think of the Y-axis. If you make a Y out of it, that's the only one that it can be. And then the horizontal axis is your X. So the Y, I go to the right, and then I go up to 10. So here it says, based on the graph, what is the unit rate? X is 1, Y is 10. That's my unit rate. 10 over 1. Now I have to include the units. If I look back at my graph, it's labeled that the Y is the diameter, or the centimeter, and the X is the number of minutes. So that means that the hot air balloon inflates at a rate of 10 centimeters per 1 minute. Now that I have my unit rate, I can write an equation. Before we write our equation, let's define our variables. I know that X, when I look at my graph, represents minutes, and Y represents the diameter, or centimeters. And so when I fill in my equation, or when I write my equation, it's just Y equals K, which is the unit rate, 10, X. Now that I have my equation, I can solve question C. I do want to note that to solve this problem, I could create a proportion and I would get the exact same answer. However, I just want to show you a different strategy that we can use to solve the same type of problem. So it says, how long would it take to inflate a balloon that has a diameter of 235 centimeters? Diameter is 235. So I know my equation is Y equals 10X. And in my equation, the Y variable represents the diameter. So I am going to substitute 235 into my equation. And so I'm going to replace the Y. So it becomes 235 equals 10X. At this point, I just have a one-step equation. And in order to solve for X, I just need to divide both sides of the equation by 10. 235 divided by 10 is 23.5 equals X. And I know X represents minutes, so that means it would take 23.5 minutes to inflate the hot air balloon. So again, you could have used a proportion, but I can also use my equation and just substitute 235 in for Y. Question D. A hot air balloon took 17 minutes to inflate. What is the diameter of the balloon? So again, using my equation, y equals 10x. This time in my equation, the x variable is represented by minutes. So I'm going to replace 17 is going to replace x. So y equals 10 times 17. When a number and a variable are next to each other, it means multiplication. When I multiply 10 times 17, I get 170. So that means that that means that if it took 17 minutes to inflate, that means the diameter of the balloon was 170 centimeters. All right, let's look at the back. Let's move to example 2. The 7th grade choir plans to sell pizzas as a fundraiser. The choir teacher created the graph below for the students. Based on the graph, what is the unit rate of profit for the pizzas? So this means that after they take into account that they had to buy materials to make the pizzas, this is the end result, how much profit they make from each pizza. This graph isn't as easy as the last one. I don't have an X value of 1 on the graph, so I can't just look at it and tell the unit rate. I need to choose a perfect point. So I'm not going to use this point here because it's in the middle. And so I would be estimating my answer. We want to try to choose a perfect point where it intersects. And so the first point that I see that's perfect is this one here. It's right on the corner. That is when I go to the right, an X value of 10, and it goes up to 12. So based on the graph, what is the unit rate? X 10, Y is 12. On this graph, the Y variable represents the profit, and X represents the number of pizzas. 12 over 10, or when I divide 12 divided by 10, I get 1.2. So Y is on top, so $1.2, because that's the profit, over X on the bottom, 1 pizza. And 1.2 really just means $1.20. So for each pizza that they sell, they only make a profit of $1.20. Now that I know the unit rate, I can write an equation. Remember, our equation is just y equals kx, but instead of k, we replace it with the unit rate. So y equals 1.2x. And when I define my variable, let's remember to write out that x represents the number of pizzas and y represents the profit or the money. All right, now let's look at question C. If the choir sells 125 pizzas, what will their profit be? So 125 pizzas represent the x variable. So in my equation, y equals 1.2x, we are going to substitute 125 in for x. So y equals 1.2 times 125. And when I multiply 1.2 times 125, I get y equals $150. So that means if they sell 125 pizzas, they only make a profit of $150. Question D. How many pizzas should the choir sell if they want to make a profit of $1,000? So when I look at my variables that I defined, I know that y is the profit or money. So this time, back to my original equation, 1.2x, $1,000 is going to replace the y because y is money. So 1,000 equals 1.2x. In order to isolate the variable and solve for the x, I have to divide. When I do 1,000 divided by 1.2, I get 833.33 repeating equals x. I can't sell a third of a pizza, so I need to round up. That means that they need to sell 834 pizzas. In this lesson, we learned how to find the unit rate from a graph, but we also learned how to write equations and how to utilize those equations to solve for unknown values. Now you should be ready to start the independent practice.